Okay, so from right now, we will start recording our webinar. Thank you again for your participation. I would like to be thankful to all the people who had find the time for our webinar. Thanks to our coordinations from a BECoop project from the Horizon 2020, which is the topic unlocking the community bioenergy potential. We had the opportunity to meet all together today and to show you a presentation and present you informations on the biomass and the potential of the biomass for being used for the bioenergy systems. I am a task leader for one of the work tasks in the work package related to the deployment of capacity building to the key actors. And this is the first webinar which will be taking place during upcoming year. We can say that academic year and also in the year 2023. There will be 10 webinars during which all the participators will increase their knowledge in the area of so-called bioenergy. So we will start first with a technical webinar, which will be just related to the biomass. And today I will explain you what is the biomass, what are the different types of biomass, how we can convert the biomass to the bioenergy, basically to the heat and to the electrical energy. And at the end of the presentation, we will also have a small amount of time, like 15 minutes, for a short discussion, if anybody will be interested in the specific content of our webinar. So we will right now start. So agenda of the webinar. At the beginning, I will say a few things about the material. A few things about what is the main objectives of our BECoop project and what is the definition of RESCOPs and BECops under which we are working. So basically, following the RED Directive, Renewable Energy Community means this is a legal entity, which in accordance with the applicable national law is based on an open and voluntary participation. Yes, it is autonomous and is also effectively controlled by the shareholders or members that are located in the proximity of renewable energy projects that are owned and developed by the legal entity. So basically the stakeholders and the members of which are natural persons, SMEs and local authorities, including municipalities as well. Primary purpose of which is provide environmental, economic and social community benefits for its shareholders or members for the local areas. To use the locally the heat and electrical energy, not to have too many benefits from that. Okay, so renewable energy communities are entity to produce, consume, store and sell renewable energy, including through renewable power purchase agreements. Share within the renewable energy community renewable energy that is produced by the production units owned by the renewable energy community, and to maintain the rights and obligations of renewable energy community members and as customers. Access all suitable energy markets, both directly through aggregation and non-discrimination manner. In the relation of the Polish law, in case of Polish Act, what is a RESCOP? This is activity of bioenergy community as the production of electricity or biogas or heat in renewable energy sources, installation, and balancing the demand of electricity or biogas or heat only for those own needs of bioenergy community. So there is no profits made on the RESCOPs in Poland, connected in the area of defined power distribution network with a related voltage lower than 110 kilowatts or gas distribution network. So what are the other issues in the relation of heat production in the RESCOPs? So limited power, the total installed capacity is limited to 10 megawatts in case of electricity, and it is limited to 30 megawatts in case of heat. There is also a limited number of members. The members of cooperative members may not exceed 1,000 participators. And also there are some issues on the limited localizations. So In the introduction, I will say you a few words about the role of the biomass in the heat production. In 2019, there was a 15.5 etajoules of heat which was produced globally via the heat plants and combined heat and power plants, CHP plants. Europe is the world leader in the production of heat from biomass in power plants, which is share of 88% globally. So renewable energy technologies, including biomass, geothermal, and solar and thermal, have doubled their share in the global heat production over the last 19 years. 97% of renewable heat produced was from biomass, with minor contribution from geothermal and solar thermal technologies. So from this, you can see what is the huge role of the biomass and what it will be in the upcoming future. On this slide, you can see that there is a prediction for the growing of our population. So in 2008, there was 6.7 billion people around the world, and the prediction for the 2050 is already 10 billion of people. It means that when we will increase nearly double with our population, there will be a huge increase in energy demand. What does it mean for us? It means that we should take care more about our natural resources and we should use the biomass. So there will be growing role of the biomass. You can see that we all the time are hitting with the climate change locally. Yes, there are huge problems in many places with the rising the temperatures around the world. And then accordingly to the forecast by rate, largest increase in the primary energy supply will be for renewable sources. By 2030, the bioenergy potential will increase by 30% and by more than 150% in 2050. You can see on that slide what is the share globally by using different kind of energy sources. You can see that in totally renewable energy sources are 6% compared to the coal, which is 23%, petroleum 39%, nuclear 8%, and natural gas 24%. And in globally, in the renewable energy share, you can see that 47% from renewable energy sources globally are coming from the biomass, which is huge potential. There is also some history behind the bioenergy and the biomass. Already 200 years ago, in 1850, ethanol was used for lighting, yes? And between 1860 and 1906, ethanol tax enacted, making it not longer competitive with kerosene or lights. So you can see that there was always some political factors which were either fosterizing using the bioenergy, either stopping it. And we are living right now in this moment in which we should again put more effort on fosterizing using the bioenergy as an energy source. More bioenergy history. In 1980, there was the first flex fuel car, the Ford Model T. So more than 110 years ago, you could run on the biofuel a car. Unfortunately, between 1920 up to 1933, the prohibition banned ethanol unless it is mixed with petroleum. Yes, World War I and World War II, ethanol was used due to the high cost of oil. Early 1960s, acetone and butanol, ethanol, industrial fermentation discontinue in the United States. Today, about 110 US ethanol refineries in operation and 75 more plants. So you can see that there is this moment in which we will use more and more biomass as the biofuel resources. So few things about how to little bit split it and to talk about different kind of biomasses which are in our possession all around the world. So basically, we have a waste biomass, which you can call a crop and forestry residues. I can show you, for example, this is a typical crop. This is sorghum, which we can use as an energy source. So basically, we have processing waste, yard waste, municipality, and solid waste. Also, sewage, industrial waste. The new type of biomass, terrestrial and aquatic, solar energy and CO2 converted via the photosynthesis to the organic compounds. We can also talk about the microalgae and algae as well, that they are the future types of biomass which you can use for the production of heat. Then agriculture and forestry wastes. As I mentioned before, we have crop residues, so those residues which are after we cut out the crops like miscanthus, for example, or topinambur, or different kind of energy crops. We have animal manures as well, food and feed processing residues, which are still in the definition of biomass. We have lodging residues, harvesting and clearing, and wood processing mill residues, which also are in the possessions of the wheel mills as residues. And there is also a big industrial market on paper and pulping waste slurries, which you can also use the lignocellulosic wastes as an output as input for the heat production. Okay, there is also, let's say, I can call it a dirty biomass, or the not so common biomass which you can use. They are basically a municipality solid waste, landfills gas to energy, and pre and post consumer residues. So this is also a huge potential, because there is a more and more biogas stations which after the fermentation has a lot of biogas solid residues which can be used after a while as a main content for the heat production. On this slide, you can also see what was the changing of annual cost of heat energy generation of the decades hours from wood briquettes and other solid biofuels and fossils, compared to the other types of fossil fuels like coal, natural gas, and heating oil. And you can see that basically throughout the forecast period, biomass fuels turned out to be the cheapest one, especially in the dynamic times in which we are living right now. I'm talking about the war between Russia and Ukraine, and also about the internal market related to the fossil fuels and to the biomass, which is now changing drastically in the last 6 months. As I mentioned before, you can see on this slide how big numbers are behind the biomass to be used for the bioenergy, especially in the European Union. Those facts are that the 95% of the bioenergy is basically used in the direct heat from renewables in 2018. In generally, in renewable energy jobs in 2019, you can see that the share of the market, it is in the possession of bioenergy 31%. Yes, so there is a lot of jobs in that area as well. If we talk about the heat production from the biomass and from the solid biofuels, you can see that nearly more than half, so 52.6% of the heat which was produced from the biomass in 2018 in European Union was coming from the solid biofuels. But what is biomass and how it is created? That's, let's say, important facts. I can spend 1 minute on that. So basically, why we call biomass a renewable energy sources. This is so-called a definition which was established by the scientists, because the biomass generally it is created thanks to the photosynthesis process and thanks to the big amount of the CO2 in the atmosphere. And this is the overall circuit which is going on all around. For example, the wood tree doesn't need millions of years to be in a high content of energy like coal, but which is just enough 100 years or 60 years to have a wood biomass which is ready for the combustion and for the production of heat. The energy crops, which you can also see on that slide, all agricultural residues are even growing much faster. Yes, miscanthus, for example, is growing in 1 year, in 2 years, in 3 years. Then agricultural waste from the corns, they are growing on a yearly basis. Yes, so the biomass is growing much faster, and it has energy content much bigger than it is in the possession of coal. And the only problem with the fossil fuels, not only problem, but problems with the fossil fuels, you can see on the table is after the combustion of it. Yes, so thanks to the replacing the fossil fuels, this is for the example between the biomass and coal, we are reducing the CO2 level 100%. Yes, because we assume that thanks to the fast circular growing of the biomass compared to the coal, this is 100% renewable. We are reducing also sulfur dioxide after combustion of the biomass by 88%. We are also reducing the nitrogen dioxide by 32%, and we are also reducing the CO levels by 79%. In sense of the particle matter totally, we compared to the coal, when we combust the biomass, we are reducing the particle matter by 43%. So a few words about the structure of this kind of typical woody biomass. Yes, basically the woody biomass is nothing else than polymer. You can see on this photograph that it is containing three types of polymers. The first, which is the blue label, which is a cover more or less, it is a lignin. Yes, it has the smallest temperature resistance. So at the beginning of any valorization process, like drying process or pyrolysis or torrefaction or combustion, lignin is first destroyed. So depolymerization starts at this layer, at lignin. Then inside the woody biomass, there are two others and two different polymers. One is cellulose, and the third one is hemicellulose. So basically, hemicellulose has a slightly higher temperature resistance. It means that between 150 up to 300 degree, the hemicellulose is under the depolymerization. So we are destroying by using the thermal effects the hemicellulose in that regime. And then the last one, the strongest polymer, is cellulose. Cellulose basically has the biggest temperature resistance, and we are depolymerizing cellulose within the temperature between 200 up to 600, 700 degree. So the final effect of the destroying this kind of polymer during the combustion process, it is around 700, 800 degree. So you can see also on the right side exactly in 3D how these polymers are together bonded and how they are created, the overall structure of this typical woody biomass like pine wood or other kind of woody biomass. Okay. On the chemical level, you can also see the structure of chemical compounds of the polymers. And this is quite interesting from the thermochemical conversion point of view for this kind of woody biomass, because basically when we are heating the woody biomass, you can see the cellulose, lignin, and hemicellulose on this photography. We are depolymerizing the OH groups. So when we are drying or when we are carbonizing the materials, I can show you how does it look after carbonization process, the typical biomass. So this is unprocessed wood chip, and after carbonization process, when we are heating the biomass with a high content, then we have this kind of effect. Carbonized wood. It looks very similar to the coal, and it's very easy to crack, to destroy. And why? It is a very simple issue. We are basically destroying, you can see on the presentation, the OH group, and because of that, it is more hydrophobic. So from one point of view, it is not containing anymore, it is not taking any more moisture from outside, but then by the depolymerization, by destroying the lignin, hemicellulose, and cellulose, we are destroying the OH groups. And because of that, it is so much easy to be destroyed. There are also benefits on that in the industrial scale systems, because we don't need to have a very expensive storage systems for biomass, which is proceed by the drying process or carbonization process. Okay, going more further with the presentation. We will say a few words about factors influencing on the biomass energy communities creations. So first of all, as I mentioned, when we are using the biomass, we are reducing of air pollution through the use of fossil fuels. Great depletion of fossil fuel deposits. Currently, coal and natural gas have combined share of more than 85% in the global heat production system. And this will need to be changed. Why? Basically because of the prices of heat, which is produced from the gas and from the coal. There is a conflict, we can say that this worldwide conflict, which is having a direct influence on the fossil fuel prices. Other benefits. We can use the bioenergy resources which are locally available. There is also willingness to reduce the phenomenon of energy poverty. So we will decrease the energy poverty by using the bioenergy. And there is a possibility of implementation of local and national policies and on the legal acts. That are the most important factors under which we are working in our BECoop project. And that's the reason why it is so much important to use the biomass. There is a slide under which you can see how does in time, in the last 40 years, there was a change in using the all kinds of renewable energy sources. So you can see that there is a huge demand of the heat which is produced from renewable sources, mostly from the biogas. So there is a lot of, in European Union, a lot of, this is the data from Eurostat, there is a lot of biogas stations which were built mostly in the countries like Germany, Denmark, Netherlands, and also France. Slowly they are also built up right now in the Central European countries and in the East European countries more and more, but you can see what kind of biggest share are right now in the renewable sources. So biogas stations and wind farms, a lot of solar photovoltaics, and also a very huge amount of the primary solid biofuels, which in which we are producing the heat mostly from the direct heating. Few words about other benefits coming from the biomass utilization. So by talking about the biomass for using for heat and electrical production, we are basically creating new jobs in the local community. So people who has working and living basically on farms, on small cities, small villages, they are using they will start to have a jobs in the place in which they are living, yes, because they need to take care about the logistic chains. They need there will be a need for hiring truck drivers to take out the biomass from one point to the second, and also to the logistic hubs in which we will accumulate the biomass for the biggest CHP stations for producing the heat. There is also benefits related to the education of resistance in the use of renewable energy sources. And remember, biomass is always and widely available renewable energy sources. We don't have this kind of problems like with wind or photovoltaics, in which we need to wait for a wind, in which we need to wait for the sun. So whenever there is a problem with the nice weather and or windy weather for the windmills, we don't have this kind of problem with the biomass. Yes, biomass is available all the time. When it is storage, it is always can be used. So this is a good source of potential heat energy. Another benefits which I already mentioned before is a carbon neutral biosolid fuel. Reduce the over-reliance of the fossil fuels. This is less expensive for sure than the fossil fuels. Biomass production as a revenue source for the manufacturers as well. We have also much less garbage in the landfills because by taking out, for example, the wastes from the energy crops or from the agriculture biomass, then we are also cleaning the landfills as well, yes. And at the end of the story, after the combustion also of the biomass, we will have ashes, which we can use as a fertilizer, yes, to grow up the biomass later on. Again, I can also tell you a few words about the heat production in the communities. Types of use of energy carriers, it was already explained on the previous slide, that there is a lot of use of the network gas, liquid gas, because 25% is the network gas, liquid gas is 7%, electricity is 11%, eco pellets coal is 0.44%, and you can see that the wood is much more used than other gases, so 29.69%, yes. Unfortunately, the hard coal is still used quite often, yes. This is of the representation for the community of Oborniki Śląskie in one of our pilot area demo place, in which we wanted at the end of our BECoop project create a RESCOP and to produce the heat and heat for the local community. Types of the use of energy carriers, yes. Assumption for the plan of heat, electricity, and gas fuel, again, for the community of Oborniki Śląskie. You can see that 50% when we talk about the types of energy carriers is coming from the coal. 75% is the electricity. Heating oil is 4% and the gas is 19%. That's the current situation. Okay. I will now show you briefly a few slides related to the project objectives as well, and we will also talk a little bit about what kind of equipment we are using for the valorization of the biomass and for the combustion of biomass, and also a few words about in which kind of form the biomass can be used as a solid biofuel. So basically, we can directly heat the biomass in the small boilers and also in the small and medium power stations. We can also indirect heat the biomass using indirect heating. So basically, we can use the district heating systems. We can also pre-convert the biomass by using the biogas plant stations. And there is also a combination of different kind of technologies. We call it polygeneration units. And there will be a theory of thermal processes, of thermochemical processes and classification, but this will already done in our webinar. And I will say a few words about the analysis of current situation on heating systems for small and medium applications. So basically, we have, as I mentioned before, different types of valorization processes in which we can even improve the quality of our briquettes. That's the final effect. So we got something which is very similar to the coal, and to produce this kind of carbonized material or torrefied material, we need to heat up the biomass in the temperature regime between 200 to 30%. If we wanted to talk about carbonization or pyrolysis, then we have to go to the highest temperatures. So you can see on this diagram that we go from 400 up to 800 degrees. There are also other pre-processing processes under which I also work in another Horizon project. They call it liquefaction and also hydrothermal carbonization. We call this kind of processes when we have the substrates which had a higher moisture content, much higher than typical woody biomass, which is after you cut the trees around 50%. But when we have the sewage sludge or municipality solid wastes, in which we have like 60 even or 70% of the water, and we wanted to use this water in the liquefaction, hydrothermal liquefaction process. And in that process, we can also pre-process the biomass, which we can later on use similarly like the pyrolysis oil as a liquid fuel. There are also more advanced processes with a higher temperature regimes, 600 degree up to 1300 degree. This process is called gasification, yes? And the typical combustion, which is between the 900 to 1500 degree. And I already present at the beginning of our webinar the logistics. How are the logistics are important in an overall bioenergy chain? So basically, it is a very important issue. Yes, when we have a close distance from the place under which we are cutting the woody biomass, so the place where we are taking out our primary source, and to the place in which we are combusting. Yes, we are producing the heat. So from the economical point of view, usually the distance shouldn't be much longer than 50 kilometers. Otherwise, there is no economical reason to combust the biomass. Yes, it's better to not combust this biomass when we need to transport the biomass on the longer distance than 50 kilometers. This distance can be extended, but only when we are valorizing the biomass in a specific biorefinery station by using the process which we just described on the slide before. Yes, like torrefaction, because thanks to this, we are increasing the caloric value. We are also having the fuel, which is cheaper in transportation and in storage. So then this distance can be extended up to 60, 100, 150 kilometers. It's basically more reasonable from a more economical point of view. Okay, my friends, slowly we are going to the end of our presentation. I also wanted to show you a little bit about new domestic bioindustry, which is a future for the biomass feedstocks, and how we can use trees, grasses, agricultural crops, agricultural residues, forest residues, animal wastes, and also, as I said before, municipal solid wastes by other processes like enzymatic fermentation, acid hydrolysis, gasification. And on the slide, you can see what kind of products you can also have after these valorization processes. So basically, you can also produce ethanol, renewable diesel, gasoline, hydrogen as well, which is a very big issue right now, the hydrogen. And also heat in cogeneration units. But what is also very important when we talk about the biomass, that we can also, by those valorization process, produce a lot of different chemicals, plastics, solvents, chemical intermediates, phenolics, furfurars, fat acids, all the byproducts which are very valuable in the chemical industry. Okay, so why growing need for sustainable electrical power can be met by other renewables? Biomass is our only renewable sources of carbon-based fuel and chemicals. This is just the biorefinery summary about the technologies which we was talking previously and to other slides. We have different kind of technologies. There is a lot of research under running how to pre-process the different kind of forestry and also agricultural biomass to have even better kind of solid fuels, which can also be used for production, for example, for kerosene, for the transport as well, for the airplanes. Yes, that we could have more sustainable flying, because right now most of the airplanes are using typically the fossil fuels for flying. So this is not really good if we wanted to talk about CO2 reduction. This is just a study case showing how the valorization process is economical valuable versus the biomass which is in the pellets, which is not carbonized. So this is a study case in Canada, from Canada, in which we are, which they are in the big possession of many forests. In Canada, we can grow the woody biomass. Yes, you can see, but we can also pre-process this biomass in Canada by using the torrefaction process, so we can carbonize. And by using this, we have pellets which are having a bigger amount of gigajoules. So 740 kilograms, it is 17 gigajoules of the torrefied pellets. But the raw pellets, 1 ton you need to have 17 gigajoules. And because of that, you have savings at the beginning of the process. Covered storage and handling system is always expensive when you have pre-processed woody pellets, raw pellets. It costs $18 per 1 ton, yes, to cover it, storage and handling in Canada. And then when you are going by ships or by transport in Canada to North America, you need to also storage outside the torrefied pellets, and the costs are only $6 per 1 ton of torrefied material. There are also savings on the transportation, because then from North America you need to transport the shipping raw pellets. It's $35 per 1 ton when you are shipping the pellets from North America to China. And shipping the raw pellets is 20% more energy dense compared to the raw pellets to the torrefied material. Then again, in the Asian port, you need to cover the storage and handling the units. So the raw pellets is also more cost effective, $18 per 1 ton, compared to the $6 of the torrefied pellets, which you are keeping outdoor. So at the end of the day, covered transport as well is cheaper for the torrefied material, and outdoor storage at the power plant in China is $0, but $8 for the storage at the power plant, because you also still need hermetic storage systems. And then you have also savings on building new feeding system for the raw pellets, but for the torrefied pellets, you don't need to have a new feeding system. You can use the existing feeding system, feeding system which was designed and built for the coal. Direct heating theory, this is what I mentioned before. We can basically either do the direct combustion to produce the heat at our homes, or we can also put the woody biomass in the bigger amount to the big systems, and then we will have indirect systems. But these systems will be explained of our next webinars, which will be upcoming in near future. Different forms of biomass. All of you know that we can have pellets, briquettes, wood chips, and logs or bulk cubes. Yes. So we can use different kind of forms of biomass. They have advantages and disadvantages, mostly in the relation of storage systems. Okay, so we are shortly finishing our webinar. There will be now 15 minutes for a short discussion. This is the slide under which we are explaining how does the torrefied material influence on the energy density, bulk density, and also increasing the amount of the caloric value compared to the untreated pellets. This was explained on our case study between Canada, North America, and China. We have, of course, different kind of briquetting systems for briquetting the biomass. We can also have a bigger briquettes for using the straw, for example, to combust the straw in the boilers. And we can also have a bigger CHP units under which we can combust the woody biomass. This slide is showing the biomass combustion, a grave stove, under which you can combust effectively the biomass. But in our next webinars, webinars related to the direct heating and producing the heat from the direct heating systems, we will show you all different kind of systems which can be used for combustion of the biomass. Okay, on the third and fourth webinar, there will be a discussion also on the district heating systems. So this is the future. This will be upcoming in a few months. And also, I would like to right now thanks to all of you who were listening to me during this webinar. And also, I'm open right now for the question time. Yes. So please raise a hand if you would like to give me any question. And I already wanted to invite you for our next webinar, which will take place in December, and then another one will be taking place in January. But I will inform you briefly before we will start to have this webinar, and I will redistribute the information through our network and also to all our friends and stakeholders. So thank you very much. Please raise the hand if you have any question concerning the presentation. Maybe anybody would like to talk about, I don't know, different kind of valorization processes, or something was unclear if we talk about the woody biomass or energy crops. Maybe everybody is interested how we can what is the future for the biomass in upcoming years, or what is the most interested type of biomass which can be used for the heat production. Okay, if there is no questions, I would like to thanks to all of you. Our webinar will be placed on our BECoop website. It will be storage there, and it will be available for all of you who would like to have use this kind of knowledge in their career. Okay, there is a question. Xaveri.
Yes.
Hello, Xaveri.
Yes, hello, Szymon. This is Xaveri. I am Xaveri Kuligowski from the Institute of Fluid Flow Machinery, Polish Academy of Sciences from Gdańsk. I have a question regarding the regionality of different biomass valorization techniques, because you've talked about combustion, torrefaction, gasification, pyrolysis, and so on. Would you be able within this project or within any other projects like to provide the region-specific maps like in Europe where these different techniques would be best applied? So the governments would know, for example, where is the best biomass availability and which technique to provide locally, because we all know that 50 kilometers it's economically feasible distance, but do we know where exactly in which regions of Europe to apply which of these valorization techniques?
Okay. Thank you very much for raising this very important issue. That was very good question for starting the discussion of during our webinar. To be telling you straight, Xaveri. So in our project called BECoop, we will have we are having four pilot area pilots in which we wanted to have build the BECoop and RESCoop. So, and basically mostly in those four of them we wanted to use a direct heating. Yes, so those four areas, this is Poland, so in Dolnośląskie Voivodeship, there is also Italy, Greece and Spain. In those four local BECoops, we wanted to use mostly direct heating, yes, and we wanted to use mostly a solid biofuel. Most of them are agro-fuel and also woody biomass. But there are also other European Union and Horizon projects which are dealing with this kind of valorization processes, because in BECoop we don't speak too much about the valorization processes. As you already know, in January we will start our project from Maria Polska-Curie called Biotrain Value Project. I also would like to welcome all of you to be our, let's say, people who will be looking on the results on that project. In Biotrain Value Project, we will do assessment of torrefaction technology, pyrolysis technology, and gasification as in-suit systems, so standalone systems, which will be pre-processing the agriculture wastes, woody biomass, energy crops, and also biogas solid residues, but not in all European Union countries, unfortunately, because it would take us too much effort. This Horizon project is limited as well with the budget and with the regions, but in all of our 7 countries, because we have 10 partners in the project. So in Biotrain Value Project, we will do the techno-economical analysis and technological foresight of this kind of technologies, and we will give you the questions on this distance, yes, level, how they will have influence on the prices and how this distance can change. We'll compare torrefaction with pyrolysis and gasification, but it will be only in the 7 countries in European Union. So it will be Ireland, Great Britain, Slovenia, Poland, Germany, Austria, and Slovenia. So I hope this is a good answer, but you know, we as a scientists are working on this on a daily basis, and as more as this kind of projects will be running in European Union, as more informations on this kind of issues we will have. I hope that was a good explanation of your question, Xavier.
Yes, thank you, Shimon. I'm sorry, maybe one more supplementary question because I missed other more biological ways of valorization. That is, for example, anaerobic digestion. Well, I know from some studies, like from some LCA studies, for example, that if you combine anaerobic digestion that result in biogas production, and then afterwards you take the residue and apply thermal methods, so you gain much more electricity. If instead of for example going directly to thermal methods, you get more heat. So maybe it would be wise somewhere in Europe where it is needed, where the electricity is equally important than heat. So in some cases, maybe would be beneficial for the users to include the biogas production step before the thermal treatment steps, especially the calorific value of the, for example, pig manure residue drops only from 16 megajoule per ton to 11 megajoule per ton. That means that you still have a lot of energy, thermal energy capacity, like heating value in the leftovers after the biological processes.
Yes, you again raise a very important problem. This is a problem not from an economical point of view or legislation point of view, but this is a typical technological problem, yes? Because this is a problem which arises with the different kind of substrates, different kind of biomass, which are more difficult to handle. This is the problem which we have been discussing during this webinar as well. So when you have a high moisture content, yes, or when you have a biological biomass like chicken manure or pig manure, which you just mentioned, then there is a higher risk of biological degradation of this kind of substrate. And the thermal treatment is a perfect issue to, let's say, solve that problem on the one hand, but on the other hand, it is also cost effective, yes, because you need to build a small biorefinery station under which, for example, you will have a torrefaction reactor and you will pre-treat this kind of wastes after the production of the biogas. So at the end of the day, everything is related to the economy. The dynamical situation under which we are living on a daily basis right now is showing that the bioenergy is becoming more and more economically reasonable. Yes, so the natural gases are more and more expensive. Coal is more and more expensive, and at the end of the day, the biomass and the animal residues are more and more interested to be closely look how we can use them more effectively. Yes, so that is very important aspects, especially in the countries like Poland, which is a very huge potential for the establishing the biogas stations, but still there is only like 100 biogas plants, and there is I think one or two biomethane biogas stations. Yes, because biomethane is a future, in my opinion, as well for the production of the heat and electrical energy here in Poland, because by production of biomethane you can easily pump in the biomethane to the existing the gas infrastructure, and by this you can pump in a renewable energy gas sources for the production of heat and electrical energy. I hope I give you the good answer for that, but this is a longer discussion in my opinion, and I think during our webinars, especially on the webinar 4, we will be strictly dedicated only to the production of the biogas, and it will be handled by our experts from Poznań, from Professor Dach, and they will explain more briefly a current situation about the biogas market in European Union, and also technical and technological solutions for pre-treatment